Welcome back. Before we're able to talk about functional programming and object-oriented programming and close this entire section out, we have to talk about composition versus inheritance first. What are those two things? And by now, we should understand their meaning, right? Inheritance is, it's a superclass, like a character over here. And remember, we've seen this code before with our elf and ogre classes. Inheritance is a superclass that is extended to smaller pieces that add or overwrite things, like here. We had elf and ogre that extended the functionality of character. We used inheritance using class extends. Composition is smaller pieces to create something bigger. We've seen that before with compose, right? We composed functions to give a function like purchase item different abilities, composed functions to act upon data differently. Smaller pieces that are combined to create something bigger. The debate between composition versus inheritance is a pretty heavy one. And a lot of people prefer composition over inheritance. So I wanted to talk to you about some of the problems that might come with inheritance and how composition might solve some of those problems. Now, what I'm about to talk about doesn't specifically mean that, hey, object-oriented programming is only inheritance and functional programming is only composition. No, you can do both things in both paradigms. However, one tends to focus more on composition, like functional programming, and one over inheritance. So in the next discussion that we're going to have here, I am generalizing and simplifying things to demonstrate what I mean. The goal is to understand some of the drawbacks that might come when using composition or inheritance. So let's get started. The first thing that we want to keep in mind when we talk about inheritance, our structure and the structure of our code is around what it is. That is, what is the character class? What is the elf class? We're structuring our classes around what things are. They have data as well as methods and actions and functions that act upon that data. With composition, on the other hand, we focus and structure our code around what it has or what it does to data. So we're focusing on what the abilities are and what it is. Now I know that's not super clear, but let's go over this. When we define something as what it is, we're saying, hey, character is going to have these properties, methods. Elf is going to have these properties and methods, and ogre is going to have these properties and methods. But what if things change? When we define things as what they are, we are saying that this is what's going to happen. But as humans, we're notoriously bad at predicting the future, right? And we're assuming no change. So let's play out this scenario. Let's say that we now find out that we need to update our game. And the character needs to have a sleep method added to it. I mean, that's fine, right? Not a big deal. Now, all my classes that extend from character will have this sleep method, which is good, but there lies a problem called the tight coupling problem. You see, the coupling between a child class and its parent is a very tight form of coupling. And what does that mean? Well, it's the opposite of reusable modular code. Because making a small change to a class, or even if we change something in the attack method, will have these rippling effects to all its subclasses. So maybe we made a small change like adding sleep, or we made a small change where the attack method does something different. Down the road, maybe the ogre class did something different to attack that now breaks things because some developer changed the parent class. And this idea of a tightly coupled inheritance where you can change things in one place and it will have rippling effects into the other can be a benefit where you keep your code dry, but can also cause a lot of problems. So you have all these dependencies where if you change something on a class, well, you have to make sure that it doesn't break anything with its subclasses. And remember, these subclasses are using inheritance. And this leads to the other problem. And let me write it down just so you get reminded. We have the tight coupling problem, which leads to the fragile base class problem with inheritance, where because the base class, in this case, the character class, changes all subclasses, this can be very fragile. Because of tight coupling, it can break our code down the path. Another problem that we might encounter with inheritance is the hierarchy problem. We only have a simple setup here with character and elf and ogre. But what if we had two different kinds of elves? We had a boss elf and a junior elf. And the boss elf or the junior elf inherits from the boss elf. The problem with this hierarchy, is that, well, what if it changes? What if the junior elf, for some reason in the game, is higher up than the hierarchy than the boss elf? And I hope you're starting to see a trend with this problem of the idea of what it is. Because with inheritance, we can start getting into a situation where we design the game with, let's say, a user in mind, then a character in mind, that is a subclass, and then we have the elf and the ogre. But then all of a sudden the game changes or we need to make an update, so we also add a watcher class, and so on and so forth. And the problem starts to arise now where we want to start sharing methods. But let's say that I have the junior elf over here, junior elf class, and the junior elf can't really do anything, maybe just sleep. So we create the junior elf. But the problem is now that because junior elf is inheriting from all these superclasses, it's going to inherit all the methods that, well, it doesn't really need. And this is the classic gorilla banana problem when it comes to inheritance, where it says, hey, I just want a banana. Give me a banana. But instead, you get a gorilla holding a banana and the entire jungle underneath it. In this case, the jungle being the user, maybe the gorilla being the character, and all you wanted was the sleep method. And then on top of that, you are just assuming that this is what it is. That is, user is going to have these methods, watcher and character is going to have the same thing, and this structure, or what we might call taxonomy, is that we're predicting that this is how it's going to be even in the future. But as soon as we start updating the game, or changing small things, or adding new classes with subtle difference, maybe changing what inherits from what, the fact that all of this is so tightly coupled, and that we inherit everything from our class, and we have to make sure that we structure our programs in a way where inheritance makes sense. And as soon as something changes where maybe the watcher has to move up a class, well, everything just becomes too tightly coupled where eventually as the program gets bigger and bigger, it creates more and more issues. And then you start to refactor the code and all of a sudden you start violating the dry principle of do not repeat yourself. If we know that some of this inheritance principles are bad, how can we fix it with composition? Well, the first thing we can do is to remove all the methods. What I mean by that? Let's demonstrate with an example. Let's create a function that creates an elf, and this elf will have name, weapon, and type. And in here, we'll just have the elf that we create, and this elf will have the name, and we can just go like this with the new ES6 syntax. And there you go. We have an elf just like we had here in our constructor, but without necessarily worrying about the character and the elf and the inheritance model. But let's say that the elf can also attack, assuming that in this class we had the attack method. Or we don't need to because, well, it inherits it. With composition, how can we do that if we're not going to do inheritance? Well, the idea with composition is it's all about what it has, the abilities that it has. So the code is structured as to what it does to the data instead of what the elf is. So the elf can attack. In that case, why not just create a function called attack that takes in the user, or in this case, the, let's say, character. And in here, we can just return object.assign, which we've seen before, and just return a new object with the attack function attached to it. So maybe we can name this to get attack ability, which allows our character to be added or have the elf character add the attack function, which can be anything. I'll just leave it blank for now. So now we can just call get attack, and we'll return from this function, and this get attack will receive the elf. And this get attack will add the attack function that we'll add in here to the elf. We're composing. Instead of just inheriting, we're saying, hey, these are the abilities that the elf has. Here's the barest elf character possible. And if we want, we can keep adding abilities to the elf. So using this method, I can say that I can keep adding things. I can say that the elf can attack. It can also, let's say, sleep. What about an ogre? Well, an ogre can attack. It can make forts, but it can also definitely sleep. Now, this is pseudocode, obviously, but I hope you understand what I'm trying to get at. We've turned this inheritance model from what the elf is, which we had here, this is what the elf is, to what the elf does. We have the base elf, but we give the elf abilities through things like getAttack, which just uses functions to add to the character object different abilities, so that we can compose these small little pieces of functionality to describe our character. And the beauty here is that state is not really created internally. getAttack simply accepts a state and returns it. Same with elf. We have a function that internally creates the elf, but then spits out a new elf object with the functionality that we need. To review, inheritance is a superclass that is extended to smaller pieces that add or overwrite things. That's inheritance. And although you can be careful with it and making sure that the base class is very, very general so that we don't overload our subclasses, it can easily get out of hand as we go deeper and deeper down the inheritance chain. And once we need to change something, it becomes really difficult. On the other hand, with composition, it's about smaller pieces that are combined to create something bigger. We combine the boxes based on what we need to create our desired output. And if we need to add something later on, well, we just add another puzzle by composing things together, or we add another box and composing things, or even remove them if we don't need them anymore. I argue, and a lot of programmers argue, that composition is a better solution long-term than inheritance. This doesn't mean that inheritance is always bad. There are ways that you can still write great code with inheritance, but the problems that might come up in the future, especially with so many unknowns and humans unable to predict the future, and all the changes that we might need to make to a program, it becomes really difficult. So composition is a good tool for you to use to keep in mind when creating software, because this is going to help us create code that is more stable as well as easier to change in the future. I'll see you in the next one. Bye-bye.